Hi guys, in the previous video on probability mass function, we did discuss about flipping two coins together and calculating probability of getting number of heads. We did create two data frames for the purpose. One was having sample space, and having created sample space like this, we derived random variable by counting the number of heads in each and every sample point. So this is what is sample point. 1, 2, 3, 4. What is a sample point? Sample point is an element of sample space. All sample points put together make a sample space. So we counted. So here we have two heads. So 2 is a random variable. Here we have one heads. Here also we have one heads. So random variable is 1 here as well as here. And then here there is no heads. Hence the random variable happens to be 0. Then having created this, we also created one more data frame with the name df underscore PMF. Here we considered unique values of these random variable, and we derived frequency of each and every random variable and then calculated probability for each and every discrete value under this random variable. And then we had drawn a graph like this. So now we will simulate this. Why? Because when we flip two coins together, ideally we should get 0.25, 0.25 and 0.5 for 0, 1 and 2 heads. But this will not happen in real world scenario. We will have to bring in the law of large numbers to make that happen. And we will do that. But before we get into simulation part, let us talk about the notations pertaining to probability mass function. So these are the notations. See here, P within parenthesis capital X is equal to X we are written. Now, why we have written this? This means that function of X. Now, what is function of X? See, this is X 0, 1, 2. And function of X is nothing but what is the corresponding value of y-axis. That is what is called function X. Now, what this small x means? This means what are the values of X? We know it is 0, 1 and 2. And when we write something like this, probability within parenthesis capital X is equal to X, we mean this. See here, P stands for probability, capital X stands for random variable, and small x represents all possible values of random variable. In this case, what are those possible values? 0, 1 and 2. So now let us expand this. Either we can write like this or we can write f of x. Same thing. So the probability of getting 1 by 4 is when x is equal to 0 and 2. When x is equal to 1, then the probability will be 1 by 2, that is 50% or 0.5. And when we are flipping two coins, and if we are counting the number of heads, we are either going to get 0 heads, 1 heads, 1 tails, or 1 tails, 1 heads, or 2 heads. That means random variable either 0, or it is 2, or it is 1. We will not get any other value. Hence it is written probability will be 0 if the x value is anything other than 0, 1, or 2. We are not going to get any other value. Fine. So the same thing is being written here in a tabular form. This is x. What is this? 0, 1, 2. These are the possible values of random variable. And this is denoted by small x. And random variable is denoted by capital X. Each and every value of random variable is denoted by small x. So what will be the probability of 0? 1 by 4. See, this is probability of x or function of x. It will be 1 by 4 if it is 0, 1 by 2 if it is 1, 1 by 4 if it is 2. And this notation, what does this means? All possible values when we sum the probability of all possible values, it will be equal to 1. Look here, 0, 1 by 4, that is 0.25. 2, 1 by 4, that is 0.25. 1, 2 by 4, that is zero point 0.5. When we sum these up, we are getting 1, and that is what is meant here. And probability of any single value of random variable will be either greater than 0 or equal to 0. It cannot be a negative number. These are the properties of probability mass function. Okay. Now let us move to simulation part. Now sample space we have created DF sample space. Let us see this. DF sample space we have already created HH, HT, TH, TT. We already created. Now what we will do? We will select from those 4 values, those 4 strings randomly, and sample size will be 100k. That we will put in a variable called samples. And for those samples, we will create a data frame and column name will be coin flip. Okay. And then we have already used this. What we will do, for every single string, we will calculate how many heads are there. So let us run and see. See, these are our coin flips TH, TT, HH, TT, TT. Look, what we are doing here in random variable, we are counting how many H are there in each and every string. The name of the column is coin flip. So here how many H? 1, 0, 2, 0, 0. And we are seeing only 5 records. So such counting has been done for all the records. So let us see the tail or as well. If it is tail, that is last 5 records. See, 99,999. That means 100k because it starts from 0. See here we have counted. Okay, done. Now what we will do as a next step, here we will create a data frame out of what? Only for this random variable. It is a repeat of everything that we did earlier. We are not doing anything different. We did it only for 4 records. Now we are doing such same thing for 100k records. Correct? So another data frame. Earlier it was data frame and data frame underscore PMF. PMF stands for probability mass function. Now we are creating a data frame df underscore sim, that is simulation. And now we are creating df underscore simulation underscore PMF. So we will take this random variable, okay? Then we will calculate frequency, correct? And then we will also calculate probability. So what is going on? Just see 0, 1, 2. These, these are our random variables and these are index numbers. So let us ignore this. What is the frequency of 0? 25,022 out of 100k. 50,157 frequency out of 100k. And 24,821 frequency out of 100k. And the probabilities are like this. So this is the final figure. So what we can do out of this? We can generate a graph like this. So what we can do is we will generate graph first for 100 samples, then for 1000 samples, then 10k, and then 100k samples. And how we are getting only this? Look, we are calculating probability for the frequency. This, and from where we are getting this frequency? From where we are getting this? Look, this we have use value counts. When we use value counts, what happens? For every single value, the counting will take place, which we already saw in the earlier video. And that is what is being done. That is fine. But let us use the table called df underscore sim, not df underscore sim underscore PMF. This is the final result is this. We are talking about this table, which has got 100k records. So from that table, we'll take first 100 record, then 1000, then 10,000, and all the records. And then we will draw a bar chart like this. See, sample size is what? 100. And what is this? This is discrete probability distribution for 100, then for 1000, then for 10,000, then 100,000. Okay, good. Having done this, now what we will do? We will create few columns so that we can draw a line chart. The line chart will show us how when the number of experiment is increasing, we will start to get exactly the desired probability for each and every discrete value. For 0, it will come around 0.25. For 1, it will be 0.5. And for 2, it will be 0.25 again. So what we are doing? We are considering that df underscore sim. What is that? 100k records. If RV is 0, then 1, else 0. What does it mean? See, look, this is what we are doing. See, this is flip coin. Random variable is what? 0. Because 0 head. HH 2. 2 heads. And TH 1 head 1. So first of all, this is random variable. So here we have created a column RV0. Here wherever in this column we have 0, we are writing 1. Else we are writing 0. In RV1 what we are doing? Wherever RV is 1, we are writing 1, else we are writing 0. And same will the case for RV2. And then we are doing cumulative sum. So see here, for this column, this is cumulative sum. For this column, here it is. And for this, this is the cumulative sum. Why we are doing that? To generate lines for each and every variable. For 0, for 1, and for 2. And what are these? These are discrete values. Right? So we have done that. So eventually what we are getting? Last row 25,022, 50,157, 24, 821. And let us match with this. With what? We already have calculated, right? Look here. 25,022, 5157, 24, 821. This frequency is coming at the end. Why? Because we are doing cumulative sum over here. So last record will show us the final sum for each and every discrete value. Having created this table, now we can draw a chart. So what we will do, see int is equal to x. What exactly is being done over here? See, int is a variable that is nothing but df underscore sim dot index plus 1. See, index starts from 0, correct? For 100k, last record will have 99,999. So this int variable will be having the number starting from 1 and it will go till 100k. Why we are doing that? So that we can directly divide by in. See what we are doing, df sim dot rv0 cumulative sum. This sum we will divide by 100k. This sum we will divide by 100k. This 100k. And what about this row? When it comes to this, we will divide by 99,999. All these values. And this one, 99,998. And the first one, it will be divided by 1. Second, it will be divided by 2. So what will happen when we will be drawing this chart for only 100 records, we will see that it will not be exactly 0.25 for 0, zero point 0.5 for 1, and 0.25 for 2. It will not be initially, but gradually it will settle at these probabilities. So this is the trend line. Let us run this. So initial 100 samples. See, lot of waves, right? Now here, initial 1000, then 10,000. Look, it is settling. And all the flips. Look, this is 0.5. That is for random variable 1. And this is 0.25 for the random variable what? 0 and 1. The simulation is done. So look, we are getting 0.25 and we are getting 0.5. That's it. The simulation is done. So that's all about probability mass function. I will see you in the next video. Thanks for watching this video.